So good morning, good afternoon, or even good evening, if that may be. This is Mr. Kanwar bringing to you the fourth lesson in space, actually the final one for a little bit. We're going to move on to a different topic. We're going to move on to some chemistry next. That will be with a different teacher, Mrs. Shiverton, and she'll be looking at the rock cycle. So that's what you've got next. So we're going to go back to planet Earth, and I'll talk a bit about that later. But this is the final lesson that we've got on space. We will come back to space in a couple of weeks' time, and then we'll carry on from where we were. It was just to mix it up a bit. Like I said, this is lesson 4. This lesson is about space exploration. So what we're looking at is basically a timeline of the events that have occurred in human history in regards to space exploration. So from the first satellite being launched to perhaps a future NASA satellite or manned space shuttle to Mars. And we'll talk a bit more about that. That's quite an exciting project that supposedly is in the pipework. So today, if it's B, it should be Wednesday the 6th of May. If it is not, it does not matter. But that's the date that this lesson should be done. Our challenge today is to name some interstellar or solar system satellites and their destinations. So that's just a factual recall on some very, very important satellites, probes, space shuttles, and so forth. And our aspire is to describe how space exploration has developed historically. So basically, essentially, be able to describe a timeline. So that's what we're looking at today. So as with any lesson, what do we need? We just need a paper and pen, or your workbook or an exercise book that you're working through. So whatever you're deciding to work through, that's all you need. And as with every lesson, we should always make sure that we recap the main points of our previous learning. So what we got? We got 4 terms, 4 galaxies, 4 different types of galaxies, I should say. So barred spiral, whirlpool spiral. I apologise, that W is a small w. Elliptical and irregular, so there are 4. You can tell this is done live because I don't go back and change it. So that's the beauty of these videos, they are done live. So you've got barred spiral, whirlpool spiral, elliptical and irregular. So if I see a mistake now, it's far too late. So what I want you to do, you're going to get around 10 seconds. An image is going to come up. Each one you can choose once, and basically you just got to match them. So here we go. Number 1 we have there. So I will label it number 1. Number 2, which galaxy type is that? Put that in green. Number 3, we will use the outward purple. So strange looking 3. And number 4, we should go with red. So there we go. 1, 2, 3, 4. Can you match them? And let us start with number 1. Hopefully I've given you enough time to come up with those answers. That one is your classic. It isn't the Milky Way. However, it is very similar to the Milky Way. We have a bar, you can see there. And essentially, we have some arms that creates a very beautiful spiral. There we go. So this one is your barred spiral one. There we go. So that's our barred spiral. Number 2. It's a strange one, this, and that in itself is your answer. It is strange, therefore it is irregular. It is not a spiral and it's not elliptical. So this is an irregular shaped galaxy. Actually, it is quite likely that what is occurring here is that it is splitting into 2. So you've got 2 galaxies, or 2 separate galaxies forming there. Number 3, your classic. It looks like water going down a plug hole. And my drawing's not so great. Oh, I've used the wrong colour. I shouldn't be using that colour, should I? It should be purple, so I will redraw that in purple to make me feel better and make it look very untidy. And that is a whirlpool spiral. So there we go. So that one is a whirlpool spiral. And then therefore our final one, even though you don't need to knock it out, but the final one is an elliptical. Okay, so it kind of looks like, you take that shape, rugby ball, American football-esque, that is your elliptical. So they are our 4 galaxy types. So that was last lesson, just to make sure that we got them all. If you haven't, then obviously you can go back and have a look. But what we are going to do now is we're going to look at some space exploration development. So let us continue. Now, space exploration started, 30s, 40s, 50s, but when it became serious was when we could actually put an organism into space. So it wasn't until 1957 when a Russian shuttle called Sputnik 2, obviously there was clearly a Sputnik 1, but this was Sputnik 2, put the first animal into space, which was a dog called Laika. And that was in 1957. The Russians did that, and they were the first ones, and this was kind of the start of the era of the space race. So it kind of fell into the Cold War aspect, and that scientific development occurred, technological advances occurred at this rate because both Russia and America were trying to kind of beat each other to improve their technological aspects to their societies, obviously to then enable them to put pressure within the Cold War that was occurring at that point. But 1957, Sputnik 2 was the first space shuttle to carry an animal, which was a dog, Laika. By 1959, we have our first image of Earth from orbit, and you can just about see it's just behind. It's just here. It's black and white. Point to it there. That was our first image of Earth. Not a great one. Well, you would think it's not a great one. Back then, it would have been brilliant because obviously this was our first thing. And for those, unfortunately, to believe that Earth is flat, here is our first evidence that it is not. So that was our first photograph of Earth from orbit, and that was from a probe called Explorer 6. By 1961, this young chap here, his name being Yuri Gagarin, travelled in Vostok 1 in 1961, and that was the first manned flight. So he was the first person in space, and there was his rocket with the shuttle being there. And it didn't take long, but in between 1961 and 1963, there were 6 Vostoks, and the 6th Vostok took the first woman into space, Valentina Tereshkova. So that was the first woman. This brilliant image here is from the 1970s. It is the first image of Earth from space in its entirety. So it's not taken from certain pictures. It's the first image of space. Now, obviously, it's been enhanced photographically, but that is the first image. So just point, just this one here is the first image of space, and you can see once again we have a sphere. But more importantly, you can just see. I mean, I'm now looking at it. You're pretty mesmerized. It's pretty mesmerizing to think that's what our planet looks like, because it looks pretty stunning, to be fair. So there we go. We're up to 1963, and by 1969, we have got probably one of the most famous images in space exploration. Here we are. Neil Armstrong and Buzz Aldrin landed on the moon with Apollo 11. So that is the photograph taken from there, and there is the, again, space shuttle and rocket that was sent. So that was Apollo 11. Apollo was a very successful space endeavour. So we had Apollo 11, 12, 13, 14, and so on and so forth. And I have not listed them here. However, do go and have a look, particularly at Apollo 13. Now, you might think that's a strange one for those of you who know a little bit of information about it, but have a look at the history and basically the tragedy of Apollo 13, because I think it's important to understand that actually space travel then, now, and in the future is actually quite dangerous. There are many things that could and can go wrong, but clearly many things can go right. But if it does go wrong, then it's really, really catastrophic for the most part. But do have a look. Now, I've not listed it here because I was only putting the main highlights, but I would like you to research the Apollo missions because I think some of them are the most fascinating ones. By 1971, just 2 years after we put people on the moon, we had our first space station, and that was called Salyut 1. Okay, that was Russian made. So that was our first space station. And then we've got this beautiful image of Venus. It looks hazy, and so here, this is Mariner 10. So that's what the space probe looks like. It was our first probe to go to Venus, and that's the image that it collected. You can see it's a hazy yellow. You can't really see the clouds, and then basically we've enhanced it through technology and the photography of that, and you can see the bands of clouds for Venus as it becomes much more clear. So that was Mariner 10 by 1974. So by 1977, NASA had realised and they were able to predict that there was going to be an alignment of planets. So you were going to get an alignment of Jupiter, Saturn, Uranus and Neptune. And what do I mean by alignment? They weren't like next to each other or anything, but if the probe was going in a certain direction, by catching the gravitational field of certain planets, it would basically fly by each one. Now remember, going back to the very first lesson when we spoke about orbits, it's very rare that you will find the orbits of planets and then the planets aligning basically side by side distance wise. So basically, so if I were to draw it, and you're going to have to apologize. So basically you have planet here, planet here, planet here, planet here. That is an alignment. Now that's rare. You're not going to get that sort of alignment because they're going, remember, around the sun in a circular fashion. So to get at the same point, here, here, and here is a rarity. And they realized, or NASA I should say, realized that that was to occur. So in 1977, what did they do? They launched Voyager 1 and Voyager 2. Both were launched in 1977, one in September and one in August, and very close to each other. And what they were trying to capture was this favourable alignment. So what did they want to get? They wanted to get to the outer planets. The image that I'm showing you now is where they are now. So they were sent in 1977. Now we've learnt about the heliosphere. Basically that is the outermost extent of our solar system that is protected. Both Voyager 1 and Voyager 2 are now, it's regarded in interstellar space. But however, we know that the next place they're going to go to, if it is existing, is the Oort cloud. So basically that's where they are currently. So they've gone out of our heliosphere. So they're going into what we regard as interstellar space. What do they look like? Very simple. They're not very big. And they're very simple. I mean, they were made in the 1970s. However, they still work. They still transmit their data back to Earth. And the whole point of those missions was to make sure that they could explore Jupiter and Saturn. That was the point. It was a bonus that they could then go on to explore Uranus and Neptune. And they are still the only ones, the only probes that have gone to Uranus and Neptune. So all our images generally from probes are from those two. However, interestingly, because they were so successful and because the technology behind the Voyager space probes was so good, they're still transmitting the data. So NASA decided, well, do you know what? Let's send them to interstellar space. What I've got for you next is a very short video, and it shows you the journey of both Voyager 1 and Voyager 2. And what it also shows you is their path, the path that they took to get to the planets, and then how they use the gravitational force field, I should say, the gravitational field around those planets, how they use that to manipulate the direction of travel for the Voyager space probes. Do have a look. So I hope you found that quite interesting with Voyager 1 and Voyager 2. And they are the bedrock of how we know what our solar system looks like. Voyager 1 and Voyager 2 were two of probably the two most important space probes that we've ever sent. And the flybys and the images that they produced and the understanding they gave us of the solar system is so important today. Because it gives us the bedrock of space exploration. And interestingly, in that video, you saw how basically if you think the solar system is like a disk, okay, so it's like a flat disk. So all the planets go around in very disk-like orbits. When the reason why we couldn't visit some of the other planets with those Voyager space probes, but when they got to the planet, it had got at that planet at a certain angle, and that meant when it reached it, the gravitational field pulled it in such a way that it took it out of the disk, and then it started to move upwards. So it went out of its plane. So you can assume, so if I were to draw, that's our disk, and you've got your planets on this plane, I should say, solar system plane we've got, okay, and our sun is here. I find it, there we go. So there we go, that's a beautiful drawing. There's our sun. And then, we've got our Voyager space probe, and it's traveling, and it's grabbing, it's getting the field strength. And then suddenly, because of the way it's come into contact with the gravitational field, it goes out and it's moving in that direction. Now, can it get to any other planet now? No, because remember, the planets are going round like so. Now it's hard to imagine, but it's like a disk, so they're going around like so. But this probe is going out, so it's going out of the solar system. Now the heliosphere is it's a sphere, isn't it? Hence heliosphere. There we go, heliosphere. Now that's the outer reaches of our solar system. So that's what's happened. Our Voyager 1 space probe has gone out, and the same as Voyager 2. So Voyager 2 did pretty much exactly the same thing, apart from the fact that it decided that when it reached, say, Neptune, it caught its gravitational field, sorry, I always keep saying field strength, I mean field, and then it went in this direction, so it went in the opposite direction to Voyager 2, and that they're both now in so-called interstellar space here, and that's what that video showed. Quite good, I thought. I've got another video coming up now, and it shows you the journey of Voyager 1 and Voyager 2. Now I think I just want you to sit back, relax and watch it, because there's some stunning imagery, and at the end of the day it's really, really difficult to understand this conceptually, but these are planets, these are worlds that are different to ours, and I want to take you on that journey. So do have a look at the video carefully, put it big screen, silence all around, and just absorb the images. So what came after Voyager? Oh, we had Galileo. So Galileo was sent in 1989. And again, the mathematics behind sending a probe is highly, highly advanced. You can see in the GIF in the right, that's currently going round, this one here. You can see how it got sent out. Now you'd think that it would just get sent straight from Earth to Jupiter. However, if you were to follow that purple line, and I know I'm going over it kind of, it comes in, then it goes out, then it comes in, then it goes out, and then it gets the slingshot, and then it gets the trajectory and the speed ready. Watch it again. It then gets a trajectory and speed to go out towards Jupiter. So it took a while. Before so it got the slingshot from the inner planets to get to Jupiter. By the time it got to Jupiter, you can see that they did exactly the same thing, but with the moons. So it caught the gravitational field of the moons and pulled it. So it created a slingshot and was able to orbit. So you can see that, there we go. So it gets closer and closer and closer, and then pulls away, and then gets closer, and then pulls away, and then gets closer and pulls away. And it's got, and how do we control it? Well, we've got jet propulsions that basically control it ever so slightly to keep it in orbit, but to make sure that it doesn't obviously crash land into any moon, so forth. So Galileo was sent to enter the orbit of Jupiter and its moons, and we sent a similar one with Cassini. So Cassini entered the orbit of Saturn and its moons, and that was in 2017. It was on the news not long, a few years ago with those images. I remember it well. And then not the final one, and these aren't, I've not included all of them, so I'm just highlighting the main ones. In 2015, the Mars exploration rover, great. It was really the first time we were able to see proper, vivid images and take soil samples and look at the Martian terrain and the landscape through that. Really, really important in terms of the development of our understanding of the planets next to us. So before we continue, we should just have a quick learning check. So paper and pen, or whatever you're writing on, or if you want to just shout out the answers and just remember them, that's absolutely fine. Number 1, what was the name of the probe that first visited Jupiter and it is now just reached interstellar space? Was it A, Cassini, B, Galileo, C, Voyager 1, or D, Sputnik? Question 2. What was the name of the rocket/shuttle that carried the first man? That was Yuri Gagarin. Was it A, Cassini, B, Vostok 1, C, Voyager 1, D, Vostok 6? Question 3. What was the name of the rocket shuttle that carried the first animal, which was a dog called Laika? Was it A, Cassini, B, Vostok 1, C, Sputnik, D, Vostok 6? Question 4. What was the name of the rocket and shuttle that carried the first men to the moon? Obviously that being Buzz Aldrin and Neil Armstrong. Was it A, Cassini, B, Vostok 1, C, Apollo 11, D, Vostok 6? And the final question, what was the name of the probe that entered Saturn's orbit and its moons? Was it A, Cassini, B, Vostok 1, C, Galileo, D, Voyager 2? Right, let's check the answers. Question number 1, what was the name of the probe that first visited Jupiter and is now just reached interstellar space? It was Galileo, B. Number 2, what was the name of the rocket shuttle that carried the first man? It was also B, and it was Vostok 1. Question 3, what was the name of the rocket shuttle that carried the first animal? It was Sputnik. Now, correction, it was actually Sputnik 2, but considering that there was no other answer there, that's the real answer. So yes, Sputnik 2 would have been absolutely precise, and the dog's name was called Laika, as I said before. Question 4, what was the name of the rocket shuttle that carried the first men to the moon? It was C, Apollo 11. And the answer to question 5, what was the name of the probe that entered Saturn's orbit and its moon? It is A, Cassini. Right, so hopefully you got a minimum of 3 out of 5 there. If you were listening to me very well, if you weren't, then perhaps go back and have a look through those questions. What we're going to look at next, I just want to go back very quickly to the Mars exploration rover. And I talk a lot about images because space is a difficult concept to understand without looking at it. And we don't get a chance to look at it. When you look at the night sky, you don't really see much. And we will come to constellations in particular because I'm quite interested in that. What do you see in that night sky? But before we do, one of the things that you can see is Mars. And we've been to Mars. But let's have a look at Mars, because I think it's quite important for us to understand what Mars actually looks like. And I don't know whether you've ever had the time to look at a video of Mars. So let us look.
This is the largest and highest resolution panorama the Curiosity rover has ever taken. It's made up of almost 1,200 individual images taken over 4 days. The rover's body is too close for the Mastcam's telephoto lens, but we were able to capture the rover using the other Mastcam lens. The higher resolution version is nearly 1.8 billion pixels. What I love about this panorama is that we can zoom way in and see details far in the distance. When you start to do that, you can see the rim of the crater we're inside of all the way to the north. Here's an impressive sight. 20 miles away is Slang Post Crater, just inside Gale Crater's rim. End to end, Slang Post is 3 miles wide. Something huge must have struck here. Whenever I start to think that Mars looks familiar, sites like this dramatic impact crater remind me that we're looking at a different planet. Curiosity is exploring a clay-bearing region on the side of a mountain. This ancient landscape was the site of lakes and streams billions of years ago. They left their clues in the finely layered, clay-rich rock. This crumbling cliff is the edge of the green Hugh pediment. It's a vast sheet of rock draped over the side of a mountain. It must have formed after the lakes disappeared and the mountain took its present shape. Did it once extend even farther out? Curiosity looks a bit like an abstract painting here. That's because this is a 360-degree perspective. The image is warped, like looking through a fisheye lens. You can make out some amazing details on the rover itself. This is the shadow of Curiosity's mast. Here's RAD, an instrument that detects radiation from the sun and space. Thanks to RAD, we have a better idea of how to protect future astronauts on Mars. Why are there severed tubes and wires on the rover? These tubes were part of the fluid cooling system that circulated throughout the spacecraft that flew the rover to Mars. These wires were like an umbilical cord for data. They were cut during landing. In spite of all the dust, our sundial still tells us to explore. Trailing behind the rover, you can see our tracks, including where we climbed up a hill. Even after 7 years on Mars, Curiosity is not done making tracks yet. Panoramas like this are like a window to another world. Explore it yourself in a 360 video. Look for the link in the description.
So that was Mars, and there was a reason why I wanted to show you that imagery of Mars, because that was the Mars exploration rover. So what's next? That's the big question. What is next? Well, it's here, Artemis. Don't know whether you've heard of it. It is NASA's next big program. And what it's about getting a crewed space flight back to the moon. We've never been back to the moon, you know, since the 1970s. So the whole point of this is for the first, and here's an interesting one, first woman and next man, so it's definitely going to be a woman, they want to land them onto the moon by 2024. So the aim is, it's 2000 now, so in 4 years' time, when you, currently in year 7 and 8, are in year 11, and you never know, hopefully we might even put it in the specifications that you actually have to learn it for GCSE, because that'd be brilliant. But by that year, 2024, we should have the first woman and the next man on the moon. And that program is called Artemis. The next stage is going to cost 35 billion, by the way. The next stage, because it started in 2017, is to get someone onto Mars. So these are the phases. So if they can get Artemis to run properly and to work, it will then be able to be a slingshot onto landing people onto Mars. So that is the next step. What I want you to do is, I'm not going to share any other information on it. I want you to search Artemis and just have a look at it, because I think it's brilliant. And you know what? And I'm not necessarily going to be political, but you know, Trump has its critics. However, by signing this, he has done one great thing. He's enabled us to now reinvigorate space exploration, which is really, I think, really fascinating and important. Another aspect of space exploration, apart from getting the next manned, is Hubble. Now we've seen lots of images by Hubble, but my final short video is a video of Hubble looking into interstellar space. Remember that space exploration isn't simply about sending people into space. It's not interstellar type movie. Oh, talking about interstellar, my recommendation, as we are off currently, is that you watch the film Interstellar. Space, black holes, which we haven't spoken about, and time dilation, i.e. the idea of space and time. All brilliant concepts. You need to watch Interstellar. So that's my movie plug. Anyway, going back to what I was talking about, which was Hubble. The next video is a fascinating look at some of the imagery of what Hubble has discovered through its own exploration of the deep space field. So I want you to, again, as my final video, I want you to sit back, think of it as a cinema, turn up the volume, make the room all dark, and have a look through space.
The NASA ESA Hubble Space Telescope has revisited one of its most iconic and popular images, the Eagle Nebula's Pillars of Creation. This time, Hubble has not just one image for us, but two. Alongside the new visible light image, the telescope used infrared light to produce a second breathtaking picture of the region. Between them, these images show the pillars in more detail than ever before. In 1995, Hubble viewed three towering spires of gas, dust, and newly forming stars within the Eagle Nebula, creating an image that was dubbed the Pillars of Creation. Hubble has observed various parts of this big nebula on different occasions throughout the years, capturing dramatic views of its cold, dark hydrogen clouds, energetic young stars, and bauble-like stellar clusters. Now, a new Hubble image shows the region in unprecedented detail. Capturing the multicolored glow of gas clouds, wispy tendrils of dark cosmic dust, and the rust-colored elephant's trunks of the nebula's famous pillars. The dust and gas in the pillars is seared by the intense radiation from young stars and eroded by strong winds from massive nearby stars. With these new images comes better contrast and a clearer view for astronomers to study how the structure of the pillars is changing over time. The new image captures almost exactly the same region as shown in 1995, but uses a newer camera installed in 2009 to capture light from glowing oxygen, hydrogen, and sulfur with greater clarity. Hubble also has an additional New Year treat for us. The telescope gazed at the same area in infrared light, allowing it to pierce through the obscuring dust and gas and unveil a more unfamiliar but just as amazing view of the pillars. In this ethereal view, the entire frame is peppered with bright stars, and baby stars are revealed as they form within the pillars themselves. The ghostly outlines of the pillars seem much more delicate when seen like this, and are silhouetted against an eerie blue haze. There have been other infrared views of the region in the past. In 2012, ESA's Herschel produced an infrared image which has been combined with an X-ray view from the XMM Newton Space Observatories to reveal the nebula's hot inner stars and their effect on their surroundings in a soup of colour. The European Southern Observatory's Very Large Telescope captured a ground-based version of the pure infrared image in 2001. But although the VLT image covers a somewhat larger area, this new Hubble image is sharper and reveals much finer details. These two new images highlight how different the universe can look when observed in different types of light, and how Hubble has evolved over time to bring us images with greater clarity for better science. As it enters its 25th year, Hubble is still going strong.
I can only give one word for those images: beautiful, because they are absolutely stunning. So we have come to the end of our lesson, so our lesson tasks. So what did we have to do today? We had the challenge of name some interstellar solar system satellites and the destinations. Hopefully we know some of those, and hopefully we are able to describe a timeline of space exploration and how it's developed historically. So our task 1 is to answer 10 multiple choice questions as it has been every single time. Our task 2, describe in no more than 150 words the journey of Voyager 1 and Voyager 2. That's on the Google form as question 11. And obviously your teachers will mark this. And then the extension task, as I said earlier, I want you to look at the Artemis program, because I think that is the future. That is your future. That's going to be space exploration future. And you know what? There will come a point where, as a species, we will need to get off this planet, because we would have used all its resources. And even if we don't use all its resources, the sun, when we do life cycle of a star, the sun will grow and envelop, i.e. it will take Earth out, essentially. So by that point, we need to have developed the technology to get off this planet. Don't worry, it's not in our lifetime. So they're your 3 tasks. Like I said, this is the last lesson of science for a while. We will come back and we will look at constellations. I think that will be in 3 or 4 weeks' time. I hope you have enjoyed these science lessons. Do make sure that you give us feedback, and actually I need to make a small apology. In lesson 2, the video was a bit dodgy. I think there was some background noise to it, so I apologize for that. We are still learning. I am still learning. This is all very new. So I will see you in 4 or 5 weeks' time. My colleagues will take over for the next couple of weeks. Keep safe and look after yourselves, and make sure that you complete your work. So, goodbye.